Hello, I'm Mrs. J, and welcome to my math class. In this one, Chapter 6, Normal Distribution, when you're looking at these, this first one, in the 1992 presidential election, Alaska's 40 election district averaged 1,809 votes. So that's your average per district for President Clinton. The standard deviation was 550. There are only 40 election districts in Alaska. The distribution of voters per district for President Clinton was bell-shaped. Let X equal the number of votes for President Clinton for any election district. Okay, so the mean and the standard deviation, when it's from the population, the whole group, 1,809, this is just your mean and your standard deviation. Now, if they said they were taking a group of 500 of them, then it would be a little different, and I think it's in a different section. But here, it's just your mean and your standard deviation, so it's the 1809, which was the mean right here, and then 505, the standard deviation. Oh, that does let me type. 550. Is 1809 a population mean or a sample? It is a population mean because it said they averaged 1,809 voters. That's the total voters. So it is a population mean. For the probability that a random selected district had fewer than 1,780 votes. Now when you're doing that, we're using, it's under distribution, so second in distribution, and then it's the second one, normal CDF. But you need a low value because it was fewer than 1,780, so you need a really low value, which you can use negative 9999999. That way then it's doing everything below up to 1,780. That would be the higher. And then you put your mean and your standard deviation, which came right from here. And then we go down and paste it and hit enter. And there's our answer, 0.479. So you're using the normal CDF. The next one, instead of saying below or above, it's actually giving us values between 1889 and 2029. So we would go back into the normal CDF. We put our lower value, which was 1889. Our higher value, which was 2029. Mean and standard deviation didn't change. Hit enter and 0.097, and that 5 will change to a 6. The next one, instead of trying to find the probability, you're given the percent and you want to find the value. The third quartile, this is the third quartile, this is the first. And they breaks it into quarters. So the third quartile has 25, 50, 75% below it. So what we use, we still go into distribution, but use the third one. And then you put your area, which in this case is the 0.75. Our mean was 1809, coming from right here. And the standard deviation was 550. And then we got 200. Of course, this 9 is going to round that up to an 80, so 2180. Let's look at another one. This one's similar. The only thing that happened here, the mean, this should have still been, the standard deviation stays the same. I wanted to look at this one, I think it was a little different. Okay, reading the problem. The patient recovery time from a particular surgical procedure is normally distributed with a mean of 4 days and a standard deviation of 1.7. So this should have been 4 and this should have been 1.7 instead of 2.89. What is the median? Well, if it's a normally distributed, the median and the mean should be the same. So it's 4. What is the z-score for a patient that took 5.8 days? Well, a z-score is your x value, which is this, minus the mean over the standard deviation. So it would be 5.8 minus, our mean was 4, divided by the standard deviation, which was 1.7. And we get 1.0588, and they want us to go 4 decimal places, 0588, and it'll stay in 8 because that's a 2. What is the probability of spending more than 3.3 days in recovery? Now, like we did on the other one, when it was fewer, we went a negative really large number to the 1780. Well, this one's more than, so we'll go 3.3 to a really large number. In distribution, the second one, normal CDF. Now for this one, we wanted 3.3 and larger. So the lower is 3.3, the larger is a really big number. Our mean from the problem was 4, it's right here. And the standard deviation, 1.7. And there's our answer. And they wanted, I think, 4 decimal places. 6597. The next one, instead of being 3.3 to the very large number, it's between 4.5 and 5.4. So we go into the distribution, down to the second one, and it was 4.5. To 5.4. The mean and the standard deviation are the same, and we hit enter twice, and we get the 0.1792. This next one, kind of similar to the quartile. We're looking for the 90th percentile. The 90th percentile means 90% of the data is below it. So if we go into distribution to the inverse norm, because this one, inverse norms when you have the percent and you're finding the value, which in this case 90th percentile means our area is 0.9. Our mean was 4 and a standard deviation of 1.7. And we get 6.1786. And I think most of these will go the same. I think the next section is when it has a sample. Yeah. Okay, let's look at this one. An average indoor cats live to 15 years old. That's our average, so this would be 15. And a standard deviation 2.2. Find the probability an indoor cat dies when it's between 16.9 and 18.8. So in between, whoops. We're looking for the probability, so it's the second one. And we wanted between 16.9 and 18.8. Standard deviation 15. Oh, sorry, mean 15, standard deviation 2.2. And we get the 0.1518. Now this one, the middle 30% of indoor cats. So we have our values. And we want the middle 30%. And they call it low and high. Now if this is normal distributed, if 30% is in here, %70 is out here. And because it's normal, it splits it equally. So 35 and 35. So I subtracted the 30 and found out here was 70%. If I take half of 70, I get 35. Because it's normally distributed, it breaks evenly, and we wanted the middle 30%, which means it has to be equal on both sides. To find this one, notice 35% of the data is below it. So we're going with the 0.35. It's the 35th percentile. So to find this value, go into distribution, the third one down, inverse norm. 35% is below it. Our mean was 15. Wait, is that the right one? Yeah, our mean is 15. Standard deviation 2.2. And we get 14 point, and then what do they want it to round to? 4 decimals. 14.1523. To find the higher value, we just need to change this. Well, this was the 35th percentile. The higher value has 35 plus 30 below it, or 65. You can hit, I think it'll bring it back up, second and enter, and it brings it back up. And we just need to change it to a 65. But everything else stayed the same. Oops. And we get our 15.8477.